Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 4 Additional Mathematics Chapter 9 Solution of Triangles HOTS question example 2. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. The following diagram shows triangle ABC. So this is the diagram ABC. Okay, so continue to read the question. Calculate the length in centimeter of AC. For the question part B, a quadrilateral ABCD is formed such that AC is the diagonal, angle ACD is equals to 35 degree and AD is equals to 8 centimeter. Find two possible values of angle ADC. Okay, so continue to read the question part C. Using the obtuse angle ADC in question part B, calculate the length in centimeter of CD and the area in centimeter square of the quadrilateral ABCD. So this is the oral question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Let us start our discussion for the question part A, where we need to calculate the length in centimeter of AC. So this is the length AC. Okay, so as you can see in this triangle diagram, the length AB is given as 10 centimeter and the length BC is given as 7 centimeter. And they already give us the angle which is 70 degree. Okay, the only thing which we require to find is the length AC. Okay, so in order to find the length AC, we can use the cosine rule, okay, to solve the question. So if you don't know the cosine rule, I'm going to show it to you now, so you can use that as your reference. Okay, so from here, let us start to solve. From here, AC square will be equals to AB square plus with BC square minus 2 times with AB times with BC, okay, and then times cos angle ABC. Okay, so this is your working. So from here, let us start to solve. Okay, so from here, AC square will be equals to 10 square plus 7 square minus 2 times with 10 times with 7, okay, and then you times with cos 70 degree. Okay, you calculate everything. So from here you should get your AC square is equals to 101.1172. Okay, so I am expressing my working in terms of 4 decimal place. Okay, so AC square is equals to 101.1172. So in order to find the AC, what you need to do is you need to square root this value. Okay, so from here, square root 101.1172. Let me underline the square root. Okay, you square root this. So from here, you should get your AC is equals to 10.06 centimeter. Okay, so this is your length of AC. Okay, let me underline the length AC. Okay, so let us proceed our discussion for the question part B now. Let us start to solve the question part B, where they ask to find two possible values of angle ADC based on the given condition, where it must be a quadrilateral ABCD such that straight line AC is the diagonal, angle ACD must be equal to 35 degree and AD must be equals to 8 centimeter. Okay, so these are the respective conditions. So the first step, what you need to do is you need to perform some sketch such that these conditions must be fulfilled. Okay, by the way, I've already completed the sketch for you, so let me copy paste the diagram now. Okay, so this is how your sketch should roughly looks like. Okay, so as you can see here, the first condition, which we need to form a quadrilateral ABCD. So as you can see here, this is the shape of a quadrilateral where you have A, B, C and D. Okay, and then straight line AC is the diagonal. Yes, it's forming a diagonal. Okay, and then angle ACD is equal to 35 degree. Okay, so angle A, C and D, you have to here 35 degree. Okay, and then straight line AD is equals to 8 centimeter. Okay, so you have here 8 centimeter. Okay, so the reason why they ask you to find two possible values of angle ADC, which is this particular angle, because they didn't mention the angle DAC. This angle is not given. Okay, if this angle is given, we would know the exact angle of angle ADC, but then DAC is not given, so there will be an assumption, guys. Okay, in this case there will be two possible values formed for the angle ADC. Okay, basically your 8 centimeter could be in this way, or your 8 centimeter could be in a way that it will be like this. Okay, where you can form your D over here. Okay, there are many possibilities. The question didn't mention the angle DAC, so that is the reason why you are going to find two possible values for angle ADC. So I hope that I've able to clarify your doubts. Okay, so enough with the talking. Now we are going to calculate the angle ADC now. Okay, so in the question part A, we have already calculated the straight line AC, which in this case is 10.06 centimeter. Okay, which is this straight line. Okay, so from here, in order to find the angle ADC, we're going to apply the sine rule over here. Okay, so if you don't know the sine rule, okay, I'm going to show it now, so you're going to use that as our reference. Okay, so let us start to solve. So from here, sine 35 degree, you divide with 8 centimeter, it will be equals to sine angle ADC. In this case, this angle is the one we are going to find now, which is angle ADC. Okay, and you divide with the straight line AC, which we already find in the question part A, which is 10.06. Okay, so let me underline the fraction. Okay, so from here, the next step will be finding the sine angle ADC. So in order to find the sine angle ADC, what you're going to do, this 10.06, we're going to times with sine 35 degree and you're going to divide with 8. So that will be our next working. So from here, sine angle ADC will be equals to 10.06, okay, times with sine 35 degree, okay, and you divide with 8. So let me underline the fraction. Okay, so you calculate this. So from here you should get sine angle ADC is equals to 0.7213. Okay, 0.7213. Okay, basically I came up with this value close to the fourth decimal place. Okay, so from here, let us continue our next step. Since I mentioned in my early discussion there will be two possible answer for angle ADC, Okay, why is that so? Because they didn't mention the angle DAC. Okay, so I hope you understand. So from here, your angle ADC will be equals to 46.16 degree. Okay, this is your first possible answer. Okay, and then for the second answer, you need to come up with the value such that it fulfills the sine angle ADC. Okay, basically in which quadrant that your sine angle will be positive. Okay, it will be in second quadrant, guys. Okay, so in order to come up with the second quadrant value, so what you do, 180 degree you minus with 46.16 degree. So in this case, 180 degree minus with 46.16 degree. Okay, you perform these calculations. So from here you get your angle ADC equals to 46.16 degree, and for the second angle you should get 133.84 degree. 133.84 degree. Okay, so let me underline the solution for the question part B. Okay, so let us proceed our discussion for the question part C now. For the question part C, we are required to find the length in centimeter of CD and the area in centimeter square of the quadrilateral ABCD based on the obtuse angle ADC that we have obtained at the end of the question part B. Okay, in this case, the obtuse angle is 133.84 degree. Okay, so in order to solve the question part C, you need to come up with another sketch. Okay, the one you are looking here right now is the sketch we have come up, assuming that angle ADC is an acute angle, but now we need to use the obtuse angle. Okay, we need to come up with the latest sketch. So I've already drawn a new diagram for you, so let me scroll this down. Okay, so this is the updated sketch. Okay, where you have angle ADC is an obtuse angle. Okay, so from here let us proceed our discussion. So in order to find the straight line CD, we can use the cosine rule, because length AC we have already find in the question part A. Length AD is given as 8 centimeter, so it will be easy for us to calculate the straight line DC. Okay, however, we do have a small problem. Okay, we still need to find out the angle DAC. Okay, because you need the corresponding angle over here. Okay, so from here the first step will be finding the angle DAC. So let us perform the calculation now. Okay, let me write the working here. So step 1, find angle DAC. Okay, in order to find the angle DAC, will be equals to (180 degree) minus with 133.84 degree. Okay, and you minus with 35 degree. Okay, so from here let us perform the calculation. So 180 degree minus 133.84 minus 35 degree. So from here you get 11.16 degree. So from here your angle DAC will be equals to 11.16 degree. Okay, so let me underline this. Okay, once we get the angle DAC, now we can proceed to find the straight line CD by using the cosine rule. Okay, so let me write in the working here. So step 2, find length CD. Okay, so by using the cosine rule, so from here CD square will be equals to, okay, so from here 8 square plus with 10.06 square minus 2 times with 8 times with 10.06, okay, and then you times with cos 11.16 degree. Okay, so if from here you perform the calculation, okay, let me perform the calculation. So 8 square plus 10.06 square minus 2 times with 8 times with 10.06, okay, and then you times with cos 11.16. So from here you should get your CD square is approximate 7.2873. 7.2873. So in order to find the length CD, what you do, you need to square root this value. So you square root this. So from here you should get your CD is equals to 2.7 centimeter. Okay, you should get your length of CD approximately 2.7 centimeter. Okay, so this is your length of CD. Let me underline the first solution. Okay, so from here we're going to proceed to our question C part 2, where we require to find the area of the quadrilateral. Okay, so from here what I'm going to do is I'm going to split this quadrilateral into two segments in terms of two triangle segment, guys. Okay, let me write here triangle 1 and triangle 2. Okay, so from here let us calculate the area of triangle 1. Let us begin with triangle 1. Okay, so to find the area will be equals to half. Okay, you can use any length or any angle. Okay, in this case I'm going to use the length AD and length AC and angle DAC over here. So from here, half times with 8 centimeter, okay, and then times with 10.06, okay, and then times with sine. Let me write this properly, sine 11.16 degree. Okay, you calculate this, you should get your area of triangle 1 is equals to 7.79 centimeter square. Okay, 7.79 centimeter square. So this is your area of triangle 1. Okay, let me underline the area of triangle 1. Okay, so once we get this, now we can proceed to calculate our area of triangle 2. Okay, let me write here the working triangle 2. So let me underline this. Okay, from here to calculate the area of triangle 2 will be equals to, okay, half times with 10 centimeter times with 7 centimeter, and then I'm going to sine 70 degree. Okay, half times with 10, okay, and then you times with 7, okay, and you times with sine 70 degree. Okay, you calculate this. You should get your area of triangle 2 is equals to 32.89 centimeter square. So from here your second area is 32.89 centimeter square. So let me underline the triangle 2. Okay, so once you get the area of triangle 1 and triangle 2, so in order to find the area of quadrilateral, so what you do, the area of triangle 1, you just plus with the area of triangle 2. Okay, so from here, the area of quadrilateral is equals to 7.79 centimeter square plus with 32.89 centimeter square. Okay, you add these two areas, so from here you should get your final answer is 40.68 centimeter square. Okay, so let me underline the solution for the question C part 2. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.